भुवनेश्वर स्थित ILS को मिली बड़ सफलता। ब्रेन मलेरिया और सीवियर मलेरिया पई औषध बाहर करिछि ILS। आउ यार जी नेतृत्व नेउछंती से होउछंती डॉक्टर भी अरुण नागराज। आउ आसंतु सीधा सड़क तांको सहित आलोचना करिबा ये जो मेडिसिन बाहर करिया पई केते समय लागिथिला एवं ये मेडिसिन किभली काम करिवो सीधा सड़क आमे आलोचना करिबा डॉक्टर भी अरुण नागराज सर को सहित। सर वेलकम टू OTV। सर व्हाई यू tried to discover this type of medicine and what inspired you to do this?
See, malaria has been a challenge. Okay, the mortality or the deaths that happen due to this, it's a huge number. Okay, almost 6 lakh people or more are actually dying, and many of them are children under 5 years of age and pregnant women, also adults. So we need to find a way by which we can actually prevent this, the death that actually happens due to cerebral as well as the severe malaria. So that is where we were very much keen to do this. It took almost 5 to 6 years for us to reach this stage. And this work has now been shown in animal models, and we have found an FDA approved antifungal drug called griseofulvin, which is being routinely used to treat the fungal diseases in children and adults, can be repurposed to prevent the deaths that happen in malaria. So we are expecting this trial to be started soon, and it may take at least 4 years for us from now to bring this drug to the market if it works well.
Sir, how it will benefit the society if the drug came to market?
It will, benefit the society by helping us to prevent the deaths that happen due to malaria. See, there is nothing like a specific treatment for severe malaria and cerebral malaria. What we do is an intravenous administration of anti-malarials like artemisinin or quinine. So that's where there is a need of an adjunct drug that can help us to prevent the mortality that happens. And the findings that we have actually published that show that it works well in animal models.
How your team was working for that?
See, we are actually working on a pathway that is involved in the synthesis of heme. Heme is a molecule that is present in hemoglobin, which is present in all our red blood cells. Malaria parasites, it actually grows in the red blood cells. It can also take hemoglobin and acquire heme through that. But in spite of it, it's also making its own heme. So we just try to understand that why does it make heme, although it can actually take from the host. That eventually helped us to find out that it is involved in the disease pathogenesis. It is involved in cerebral and severe malaria. Then we try to answer that whether we can use a drug that can inhibit the synthesis of heme in the malaria parasite that can be used in humans for the prevention of the deaths.
गोटे बड़ सफलता एवं गोटे गर्वर विषय। भुवनेश्वर कैमरा पर्सन अनंत वासुदेव सह कपिलेन्द्र प्रधान OTV।